Saxon Advanced Math, Lesson 89. This is the Ellipse version 2. We're going to get a little more in depth in the ellipse and talk about how we can find different values with what we know. Now, in order to do so, we need to get a couple of review definitions. First of all, these are the equations of an ellipse. This is a horizontal and a vertical ellipse, and it just depends on which one we're going to be working with. Notice the only difference between the horizontal and the vertical is the horizontal has a under the x, and the vertical has a under the y, which a good rule of thumb is that the a value is always larger. That's how you know where to put it. And the a value will determine whether it's a horizontal or a vertical axis. Okay, now let's go ahead or a horizontal or vertical ellipse. Let's go ahead and talk about a couple of things we also are going to define. Remember that an ellipse is formed if I were to take and I've already got this written out here, take a string and drag that string around my two focal points. As I do so, I would have this line first, right? And the string would be this one plus this one. And if I went down to this next one and I pulled it this direction, it would be this one, right? And this one. And here I'm pulling the string, and notice that this part of the string is getting longer as this one's getting shorter. Okay, so at this point, notice that this one is almost the nothing left, right? But as it gets down to here and it lays down on there, the string is actually laying on top of itself right here. So it goes there, back, and then all the way over to here. Therefore, this distance, the string is going over, laying on top of itself. This is only one part of the string. If I were to take the one part off of here and stick it here, it would fit equally, which means that the length from here to here is automatically going to have a value of 2a. Now, where does a come in? A is the value if I were to come and put this line right here up on this and come down. Now, I've drawn it here. This is a and this is a, and the two a's are going to be equal in that sense. So in other words, this line is the same as this line because they're exactly in the middle, right? I'm taking that half the string is on either side of my pencil mark. So at that point, that's what a value is. Well, if I looked at it, I would realize that the total length of the string is a plus a, right? It goes up a, down a. And that 2a is also, therefore, the length from here to here, which means my major axis is always 2 times a. Well, because we're going to use that a in our formula, right? A squared and a squared, we can derive the Pythagorean theorem from this and use this because at this point it's sitting on this triangle. If I only look at half of that triangle, I realize that I have a value of a here. Now, in this sense, a is my hypotenuse. So don't get confused. I know a lot of people are going to look at it and say, hey, your Pythagorean theorem, c squared equals a squared plus b squared. Why are you saying a squared? Well, I'm going to pretend my hypotenuse is a because I can label it whatever letter of the alphabet I want, and I'm already using a in my normal formula. So I'm going to say the hypotenuse is a, which in that definition, the hypotenuse squared equals the addition of the square of the other two legs, right? That's a pretty simple way of saying it. So if I relabel them A, B, and C, it doesn't matter which value of A, B, and C I use. I just remember the hypotenuse has to be the longest side, and that has to be on the side by itself. I can come up with a squared equals b squared plus c squared. And I realize that's using the Pythagorean theorem. It's not the correct letters of the Pythagorean theorem. Just go with the fact that the a in this case is the hypotenuse because of an ellipse, not because a squared would be a leg in a normal triangle. Okay? Now I know that's a little bit confusing, but that's what happens when we only have so many letters in the alphabet, right? Is we start reusing them. And in this case, we're reusing the hypotenuse as a, so it's hypotenuse squared equals leg squared plus leg squared. And so in this one, it's going to be a squared equals b squared plus c squared. Now, once I know that, I can start to determine a couple of things that I am going to be able to use for finding out the other parts of my ellipse. Look at example 89.1. Write the standard form of an ellipse with vertices at plus or minus 5 and the foci at plus or minus 4. Now, the book says it like 4 times in this lesson. Always start with the diagram. It's not a bad idea. They're not just saying that because they're running out of words or things to write. The reason why is a diagram will help you with determining it. Now, I already know which way this ellipse is going to lie, vertical or horizontal. And the reason why I know that is because if you notice, on a horizontal, the foci lie on the x-axis. On the vertical, the foci lie on the y-axis. And since they're telling me that this is going to be on, the vertices are going to lie on the, I've got vertices at plus or minus 5, and the foci are lying on plus or minus 4, that's on the x-axis. I know it's a horizontal ellipse. Now, once I do this and I get this graph, I can start labeling a couple things. If this is 4, right, that's our difference on our foci. The distance from here to here is 5, which means the distance from here to here is 10, right? Because plus or minus 5, 5 minus a negative 5 is 10. That means 2 times A equals 10. Well, that comes into handy because then can I find out what A is? Certainly. Half of 10 is 5, and that's going to give me a value of A. So A is 5. If A is 5, now I have this little triangle right here, right? And I can say 4 squared plus my B squared. And I know it's B because, why I know this one's going to be, is B and not C, because I already know that I'm going to be using A and B for my axis points, for my axes. So I know that it has to be the B value. So I can say 5 squared equals 4 squared plus B squared. 25 equals 16 plus B squared. So B squared equals 9. Oh, there we go. Do we know A? Sure we do. We knew A from before because we knew that 2A is 10, so A is 5. And we can therefore say 5 squared is 25. So I can now write my formula putting my A underneath the x because it's horizontal. And I get x squared over 25 plus y squared over 9 equals 1. Now, let's go ahead and take this a little bit further and make it a little more exciting. I'm skipping 89.2 because it's the same exact idea, with the only difference being that they're using a vertical ellipse. And you have to realize, hey, the vertical ellipse means that it's going to be, the A is underneath the Y. Now, 89.3, a horizontal ellipse has a major axis of 10 and a minor axis of 4. If it's centered at the origin, find the foci and write the equation in standard form. So I know a couple of things. The major axis is of 10. So that means that my distance from this, plus or minus, right, is going to be 5. And our minor axis of 4, so plus or minus 2. So I can, on the minor axis. So I can very easily sketch this out to begin with, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is going to be my major axis, my minor axis, 1, 2. And of course my graph is not very good, like it always is, always a little off, right? But I therefore can say, well, okay, now what would I do to find out the other value? Well, I need to find out what C is. Do I know A? Sure I do. So I'm going to say, well, what is A? Well, 5 squared, right? So 5 squared, for A, 5 squared equals C squared plus B squared. Well, what is my B squared? Plus or minus 2. Okay, so once again, 2A equals 10, so A equals 5. So then I say 5 squared equals C squared plus 4. So 21 equals C squared. The root of 21 is C, and I can write the points of the axes. I can write their values now and say it's negative root 21 and 0 and root 21 and 0, which is just over 4, right? Because 4 squared is 16, 5 squared is 25. It's between 4 and 5, so, and that's why it doesn't matter, it's just a sketch. So next thing I do is I need to write the equation. Well, I know that it's going to be the A squared under the X because it's a horizontal ellipse. So I'm going to put X squared over 5 squared. My B squared, which I found, right, already was plus or minus 2 over 2 squared, and I get X squared over 25 equals Y squared over, there we go with my happy writing here. Those are pluses. X squared over 25 plus Y squared over 4 equals 1. Now, these are not terribly difficult. These do require you to do a little bit of thinking. Always start with your graph. It will save you a lot in the end because if you'll know where to put your values of A and B.